Today's lesson, I am going to run through the elimination mechanism, and there's two versions of this, the E2 mechanism and the E1. But before I start, it's worth mentioning that I've done a video on the nucleophilic substitution mechanism, which covers the SN1 and SN2 varieties of that mechanism. So I strongly suggest you watch that first because they are analogous to what I'm about to explain here, in the case of the E2 mechanism being similar to the SN2 mechanism and the E1 mechanism being analogous to the SN1 mechanism. So we have a primary haloalkane, and you can see the hydroxide is in a solvent of ethanol and is producing an alkene. The first step is to always put in any relevant dipoles to show where the reactive site might be. So we're obviously going to have the delta plus and delta minus on the CCl bond. And then the hydroxide is obviously doing something to get that chlorine off. Normally, hydroxide acts as a nucleophile and you would make ethanol. However, that only happens in a solvent of water where the hydroxide can act as a nucleophile. When the solvent is ethanol, the hydroxide acts as a base instead. So that's really important. Now let's recap the definition of a base. A base, or an alkali, accepts H+, usually in an acid-base reaction. So that's exactly what happens here. The hydroxide takes a hydrogen off this molecule to form water. So when the solvent is ethanol, OH- acts as a base, and then just because it's relevant, if the solvent is water, hydroxide acts as a nucleophile. And as I've said, I've covered that in the previous video on this. The link is below in the description for this video. Lone pair is attracted to the H. The CCH bond breaks and the electrons collapse into the space between the CC bond there to create a double bond. And then at the same time, the chlorine is kicked out. So this happens all in one go. And we have the creation of a water molecule. So the OH plus the H makes water. We have ethene being made. So that extra pair of electrons forms a pi bond. The pi and the sigma make the double bond. And then the chlorine is kicked out. So that chlorine then would obviously pair with Na plus if you're writing a balance equation, and you'd make salt. But leave out the Na plus because it's just a spectator ion. So to summarize, solvent is ethanol. Then OH- acts as a base and you get the creation of a double bond. If the solvent is water, you have nucleophilic substitution instead. And you would make, in this case, for this molecule, it would be ethanol. Right, this time we have a tertiary haloalkane. And by the way, ETOH is just a shorthand for ethanol. This time the base is sodium ethoxide. So let me just show you what that looks like. So it's Na plus and then O minus CH2, CH3. So slightly different base this time for this reaction, although hydroxide will work as well. In this one, the E1 mechanism is really similar to the SN1 mechanism because both involve the formation of a tertiary carbocation. In the first step, the bromine is the species that leaves, but the double bond is not created then. So if I just draw this one fully so we got some clarity here. So this just drops off. Then we're left with CH3, then we have the C, and then we have a positive charge there. And then H, H, H. You'll see why I'm drawing that out fully in a moment. And just as I discussed in the previous video on the nucleophilic substitution mechanism, just use a different color here. This is a tertiary cation. So that means it's stable. Then it's going to be a lower energy state. And so it's going to be formed. So this is why a tertiary haloalkane goes by the E1 mechanism because of the possibility of the tertiary cation being formed. Now in the last step, the ethoxide, which is, if I just draw here, is the O minus, you've got your lone pair there, CH2, CH3, that comes in and grabs this hydrogen there, and then the electrons from that CH bond collapse into the double bond there, and we make CH3, carbon, we got the formation of a double bond, and then we have the CH3 there, which is our product there. To summarize, the E1 mechanism is similar to the SN1 mechanism, because both involve the formation of a tertiary cation, whereas the E2 mechanism is similar to the SN2 mechanism because everything sort of happens in one go in that first stage. So I hope that was helpful, and if you have any questions, please comment down below and I will get back to you as soon as I can. Otherwise, I will see you in the next one.